Today, I'd like to introduce the ECG test mode of WailTech AECG100. This simulator generates various signals, including sine waves, triangle waves, square waves, rectangle pulse waves, and ECG waveforms. Select the sine wave, and you can adjust its amplitude. For ECG waveforms, the amplitudes of R, T, and P waves are all adjustable. You can also adjust the frequency, and the BPM, beats per minute, will automatically change with the frequency. Additionally, you can select RA or LA electrodes for the output. Currently, LA is selected, so the configured sine wave will be sent via the LA electrode. The LA electrode terminal of the AECG100 is connected to the LA electrode of the ECG machine. When both LA and RA electrode terminals are connected to the ECG machine, click play and you'll see the ECG machine displaying a sine wave on lead 1, set at 1 Hz and 1 millivolt in the AECG100 software. Furthermore, the AECG100 has an essential feature called Standard Assistant that supports compliance tests for 2 standards, IEC 60601-2-47 and YWISE 0885. Take IEC 60601-2-47 as an example. It includes tests like 201.12.4.4.101, 102, 104, etc. Click Linearity and Dynamic Range, and the test parameter settings will automatically appear. Now, select LA as the output electrode. The amplitudes to be tested include 0.5 millivolt, 1 millivolt, 2 millivolt, etc. And DC offset needs testing at plus 300 millivolt and minus 300 millivolt. After setting the values, click Run, and the AECG100 will automatically output the configured signal to the ECG machine. Set the DC offset at plus 300 millivolt and click Run to conduct another test. The difference between the 2 tests lies in whether there's plus 300 millivolt, and the error in the test results must not exceed 10%. Using this Standard Assistant function makes testing much easier. For example, selecting LA as the output electrode, setting amplitude as 0.5 millivolt and DC offset as 0 millivolt plus 300 millivolt and minus 300 millivolt, you need to test a total of 4 times. When the amplitude is 1 millivolt, 2 millivolt and 10 millivolt, each requires 4 tests. So there are 16 tests in total, and the error in each test result must be within plus or minus 10%. By directly clicking to set parameters through the Standard Assistant function, you can save a lot of time during testing. Take another example, input impedance. Similarly, select an output electrode and set DC offset as 0 millivolt, plus 300 millivolt, and minus 300 millivolt, and additionally set an input impedance of 620 kilo ohm. Now, select LA as the output electrode, set the DC offset as 0 millivolt, and click Run. The output signal is 5 millivolt, and you'll see the same 5 millivolt signal on the ECG machine. After the test, add the input impedance of 620 kilo ohm, then click Run. You'll notice a slight change in the output signal. Let's compare the two signals. The amplitude with 620 kilo ohm should not differ by more than 6% compared to the amplitude without 620 kilo ohm, which means the input impedance should not fall below 10 megaohm. So, set a sine wave at 10 Hz and 5 millivolt with DC offset at 0 millivolt via the LA electrode and test without 620 kilo ohm first, then test by adding 620 kilo ohm and make the comparison. Also, select DC offset as plus 300 millivolt and minus 300 millivolt for 2 tests each, making it a total of 6 tests. All the amplitude differences with and without 620 kilo ohm should not exceed 6%, and that's the completion of the input impedance test. Through manual parameter settings by the user with the standard assistant function, the AECG100 can test all items in a short time. Secondly, I'd like to introduce the PPG test mode of AECG100. For the PPG test mode, the primary setting is to control the light intensity emitted by the AECG100. The light intensity includes 2 parameters, DC and PI. DC represents the green LED intensity of AECG100. PI, perfusion index, is related to AC, representing the size of artery perfusion. PI is defined as the ratio of AC to DC times 100%. So a PI value of 2% means it is only 2% of the DC value. You can select PPG, sine wave, or triangle wave as the AC waveform. Taking PPG as an example, you can adjust its parameters, including SP value, DN value, and DP value, either through the waveform or manually input. Their time unit is in milliseconds, and you can also set their values. Once the light intensity and PI value are set, click play, and the AECG100 will output the signal. Take a look at the green LED of AECG100. It may appear unchanged to the naked eye. However, it actually contains DC and AC signals. Since the AC signal is too small, the naked eye cannot recognize its changes. Nevertheless, they can be detected by the DUT. Let's test the heart rate function of the DUT. Change the BPM value to 60 and place the DUT on AECG100. The original heart rate value displayed by the DUT is 68. After detecting the light signal outputted from AECG100, it gradually becomes 60. The required time depends on the algorithm of the DUT. The more PPG signals the DUT detects, the higher its accuracy. For this DUT, it takes about 10 seconds, and the displayed heart rate matches the value set in AECG100. Therefore, setting the intensity of DC and PI allows the DUT to detect. DC represents the color brightness of the skin, and PI represents the size of artery perfusion. People with different arterial elasticity, such as those with arteriosclerosis, healthy individuals, or athletes, exhibit different PI values. The AECG100 aims to simulate those conditions to test the DUT. Additionally, the built-in PD photodiode in AECG100 can detect the LED behavior of the DUT, including emitted light intensity and time intervals. This allows you to check whether the DUT LED is functioning normally. The AECG100 also supports raw data playback as playing recorded waveforms, such as clinical data. Playing raw data can test whether the DUT can detect real signals. If the waveform is a signal with a disease, such as AF, atrial fibrillation, and the DUT has an AF interpretation function, you can test the accuracy of this function by playing the AF waveform. Thirdly, I'd like to introduce the PWTT test mode of AECG100. PWTT stands for pulse wave transit time, the time it takes for a pulse wave to travel. Its principle starts with the electrocardiogram. Let me use the ECG test mode of AECG100 to explain. After selecting the ECG waveform, you'll see the PQRST waves, representing the heart's electrical signal. The heart begins to beat through the transmission of this electrical signal. When the beat reaches the wrist through the artery, wearable devices are commonly used to measure its PPG signal. Thus, the electrical signal comes first, followed by the PPG signal. The time difference between the generation of the electrical signal and the measurement of the PPG signal on the wrist can be used to calculate blood pressure values. Different DUTs have their own calculation methods according to each manufacturer. The AECG100 can simulate the time difference between ECG and PPG signals. In the ECG test mode, you can see the PQRST waves of the ECG signal, and in the PPG test mode, you can see the PPG signal. In the PWTT test mode, you can set their time difference parameters. PTTP represents the time difference from the R wave to the peak of the PPG waveform. And PTTF represents the time difference from the R wave to the trough of the PPG waveform. Using the maximum and minimum values of the PPG waveform and the time interval from the R wave, the AECG100 can simulate various situations. Adjust the PTTP value, the waveform will change accordingly. Then click Play. The played waveform is the configured R wave and PPG waveform, simulating the time difference. These signals are outputted to the DUT to test its blood pressure calculation function. Lastly, I'd like to introduce the auto sequence function of AECG100. Let me use the ECG test mode as an example. Set the amplitude to 1 millivolt and save it as Mode A. Therefore, when the AECG100 standalone operation is performed, you can press the Mode button on the AECG100 to switch it to Mode A and output the saved ECG signal. Additionally, Mode A can be added to the auto sequence page as the first test item, generating a 10-second signal output. As the screen shows, Mode B stores the PPG parameter settings, and Mode C stores the PWTT parameter settings. In addition to these three tests, you may need other tests. Adjust parameters in the ECG and PPG test modes, then save them as new test items. Take adding a new PWTT test as an example. You can also choose previously saved signals from the computer, then click OK to load it to the test list. From the right side of the screen, you can see the parameter differences between this PWTT test and Mode C. After setting up the tests on the auto sequence page, click play and the AECG100 will start playing Mode A for 10 seconds, followed by Mode B for 10 seconds, then Mode C, ECG, PPG, and PWTT in sequence. With this automated testing setup, you can save a lot of time and workforce. We've come to the end of our introduction to the AECG100. Thank you for your time.